This is question 2. Question 2 asks, which strategy can be used to subtract 3 1/5 minus 2 1/3? And there's 4 choices. In the choices, it has the student change each of these mixed numbers into improper fractions. So in order to do that, we are saying how many total fifths there are in 3 1/5. So if this is 3 wholes, that's actually 15 fifths, because it's 5 fifths and another 5 fifths and another 5 fifths for a total of 15. 5, 10, 15. And then we have this 1 fifth. So we add 15 and 1, that makes 16 fifths. And then we do the same thing for 2 1/3, only this one we're dealing with thirds. So we have 6 thirds total here, because it's 2 wholes is 3 thirds and another 3 thirds. And we have 1, so that's 3, 6, and 1 more is 7. So what we end up with 16 fifths minus 7 thirds. And then we know, we've worked on this over and over and over. We know that we cannot add or subtract fractions until we have a common denominator. So in order to make these denominators the same, we have to find what amount we need. So I talk about a table. We have fifths, and we have thirds, and then we count by fives and we count by thirds until we find one that's the same. So 5, 10, 15, 20, then I'm going to go 3, 6, 9, 12, 15, and then we see that we have 15 the same. So the strategy becomes, I need to make both of these 15ths. So I know that 5 times 3 is 15. So it becomes 16 fifths times 3. And whatever we do to the bottom, we also have to do to the top. So that becomes times 3. And then minus 7 thirds. And I know 3 times 5 makes 15, so times 5. And same thing up here, times 5. And that equals 16 times 3 is 48 fifteenths. And 7 times 5 is 35 fifteenths. And now we have them both fifteenths. So we can subtract 48 minus 35 is 13 fifteenths. And that's how you do question number 2.